Hello, my name is Robin Couteur, and the purpose of this video is to show what I've done in AWS for my NET702 assignment 2. Right, so let's start off. So first of all, we'll go through IAM. So in IAM, I've created a few different groups here for my users. So the first group is the system admins group. So system admins group has got the system administrator role attached, the policy, sorry, and I've also got this other policy I created called force MFA. So what this does is it does not allow the administrators in this group to use any of the features of AWS unless they set up MFA. So unless they have MFA, they can't do anything. Let's have a look at the next one. The next one was the database admins. So they have the database administrator policy and force MFA as well to satisfy GoGreen's requirement of having MFA on all administrators. And then we have the monitoring group, so they can read all the different services there, but they cannot edit anything. So here's the users. We can see all the users, and obviously there's my account for AWS. Roles. Oh yes, that's right. So I created a role here called EC2 to S3 read write. So that allows the application tier that has that role to access the S3 and read and write to buckets. There's a few different policies here. We can have a look at my force MFA policy. So we can see that we can do all this. So this is something I found on the internet somewhere. So yeah, seems to work all right. Right, let's move on to the next section. So the next thing we'll go through is EC2. So in EC2, currently there are a few different instances running here. So I've got my app tier and web tier instances. Web tier's got 3 for some reason, but yeah. Which template? Security groups. Nah, security groups will be in VPC. We'll look at that a little bit later. Load balancers. So I've got 2 load balancers here. One's for the web tier, so that's an externally accessible one. So that provides internet access. So from the internet, you can point to that load balancer, and then that load balancer will route to my web instances. Then the internal web app load balancer will route traffic from coming from the web instances going to the app, and they will go to that load balancer and then spread out to all the different app instances. So here we have two target groups here. The app, you can see we've got some instances in that. Same with that. For some reason these are unhealthy. I tried troubleshooting. We had problems with this last semester as well, where there was some instances unhealthy. Last project, it seemed to work fine, but for this, I don't know. I've checked all the security groups and everything, but it just doesn't seem to like it. But other than that, it's yeah, the instances are there. They just don't want to communicate. Yeah, and so yeah, it's pointing to HTTP port 80 because that was the simplest. Obviously, that's not the same in the documentation. So we have 2 launch configurations here, one for the app tier and one for the web tier. So in this, they're pretty much the same because I decided to put web servers on both so that the load balancers would work, which unfortunately doesn't work for the web tier, even though they're pretty much exactly the same. But those launch configurations are used for the auto-scaling groups here. So these auto-scaling groups will create and remove instances. When they create instances, they will use those launch configurations to define what the instances will look like when they're loaded up. So we've got different scaling policies for this one. So for the web, we have a policy here which maintains the average network in at 65%. So there'll be 65% load per instance in the web tier. If it goes much higher, it'll automatically scale as required. I haven't made any particularly fancy policies there, but yeah, it'll just keep hovering around there, which is what is required. The app tier scales based on CPU utilization. Obviously for GoGreen's requirement, it should be a CPU and memory, but there is not an immediately accessible memory utilization at 55% as there is for a simple policy. So what I would do for that is I would have to create a more advanced one where it checks what the memory usage is. But yeah, that's not too complicated to do. Just didn't have enough time, unfortunately. Right, let's have a look at the next one. So in VPC, so we can see I have got my GoGreen insurance company production VPC. So I only created production, not the test and dev. Subnets, so I've got 8 subnets. So I've got public subnets, one for each AZ. So this is a 2 AZ network, one for each AZ. So public, web, app, and database, and they're all separate. The public ones are /27s because they don't need as many instances in them. Route tables, so I've got 3 route tables here. Public route table is associated with the 2 public networks, so I'll just pull this up a bit. So we've got the two public subnets, and they're associated with this, and this directs all traffic out to the internet gateway, which we can see here. So we have an internet gateway here attached to my VPC. And then we have 2 private ones for the app tier, because it was specified that the app tier has to have internet access while still being hidden from the network. So they go through NAT instances. So this one here is associated with the first subnet, and this one is associated with the other subnet. And each one routes to the NAT instance in the same AZ. So each of these is one app tier can only communicate with its AZ's NAT instance, and then the other one is for the other one's NAT instance. And we can see the 2 NAT instances here. So these have got elastic IPs. So these NAT instances allow the app tier to access the internet without being directly connected to the internet with a public IP. So that's a bit of security for that. So that's used to patch the instances and stuff because they can use the internet. We didn't do any of those. Security groups. So I've got a few different security groups here. First is the web ELB security group. So that one is that one allows traffic from anywhere in the internet on port 80 for simplicity. So that would best practice would be to use SSL. So I'd have port 443, but we won't do that for this because this is just a simple VPC. Then the next one is the web tier. So after the traffic goes into the load balancer, then the load balancer feeds it to the web tier. So the web tier only allows traffic from the web load balancer security group. So the load balancer is attached to that security group. Well, the security group is attached to the load balancer. Then next is the app load balancer. So the app load balancer security group allows traffic only from the web tier. So web instances will communicate with the app tier through the app load balancer. And then the same thing as with the web thing, the app tier only allows from the app load balancer. And then the database tier only allows from the app tier. So it's all step down. You can only go one step at a time. You can't skip layers. So that adds a few layers of security because you can only go one step at a time. Right, let's have a look. Next is RDS. So I created a single database instance here. So I've got the GoGreen insurance company database. So that's just a MySQL database. I use a T2 Micro, obviously, because I don't have thousands of dollars to spend on a big instance. This one can't be created as multi-AZ because it's too small, but there's a little checkbox which you can select to make it multi-AZ, and then it just automatically creates a second read-only database in a different AZ. So if one AZ goes down or one, the database fails, then we've got a live system there ready to go. Yep, so that's that. And that's sitting in a subnet group. So I've got a subnet group for this, which is attached to the app tier and the database tier subnets. So that, yeah, that's that. SNS. So SNS, the purpose for this is to email administrators whenever there's more than 100 HTTPS 400 errors within a minute. So I've just kind of put my email in there. So that would mean that I would subscribe to that. I could set up a more complicated thing where if I gave emails to each of the administrator accounts, I could make them automatically subscribe, but I didn't do anything fancy with that. This is just a basic SNS topic to prove that I know how to do it. If I was to actually make it work properly, I would have to set up an alarm here. The alarm I haven't created one because not everything's quite working as intended, but I would have to create an alarm, and I could go and select a metric, and if it was all working properly, I could find the HTTP 400 errors, and then I could set up a rule that if there's more than 100 in a minute, then to set off the alarm, and then the alarm can trigger the SNS topic, can publish to the SNS topic, and then the SNS topic will then send out that message to all the subscribed administrators. So it doesn't matter how many administrators I have, I can add more, take away some, as long as they're subscribed to that single topic, then they'll get the message. So that SNS is basically just the middleman. So it's one thing that the alarms triggers, and then that just fans it out to all the subscribers. So that's pretty much all I did for my project. I hope that's all suitable, and thank you for listening.